My name is Gert Kootstra. I'm an associate professor here at the Wageningen University in Research. I have an expertise in computer vision and robotics applied in agriculture. And I'm also the scientific director of the AI for Agri-Food Lab.
Hi, my name is Akshay. I'm doing my final year of PhD at Wageningen University. I have a bachelor's degree in electrical engineering and a master's in systems control and robotics. So in my work, I work with active perception. So I try to develop algorithms where the robot reasons about occlusions in the environment. So where objects are hidden from its view, and it reasons about the environment and plants a new viewpoint so it can observe the plant paths much better.
If you want to apply robotics in agriculture, there are three main challenges for these robots to deal with the environment. The first is variation. So if you look at, for instance, behind me in the greenhouse, you can see that every plant looks completely different. At the same time, lighting conditions change over the day. It might be a sunny day or a cloudy day, it might be moisture or not. So there's a lot of variation that we need to deal with. On the other hand, robots also have to deal with an incomplete picture of their environment. As you can see in the background here, a tomato greenhouse is a very cluttered environment, which means that there's a lot of occlusion, so robots can only see part of the environment and still they need to make their decisions based on that information. And the third challenge is that plants and the produce of these plants are very fragile, so the safe interaction of a robot with these plants and fruits is a big challenge for robotics. In this lab we mainly focus on the perception aspects. So we're applying AI technologies to go for more robust perception systems and the use of multi-view and active perception methods where a robot actively gathers the information that it needs to perform its task. I think it would be fair to say that we're not a university developing the hardcore AI technologies, but we're applying existing technologies in the agricultural context. And by doing so, we learn a lot about specific challenges that we have in agriculture, such as the variation and occlusions that I already mentioned. But there are other challenges, like there's a limited amount of data available to train AI models. Things need to be very, very accurate because a farmer will not rely on a system that has a 80% MAP. It needs to work 99.9% perfect. And the costs and the profit margins are very low, so the cost needs to be very, very low as well. And by having these conditions, we can bring something back into the AI community also by having challenges that are very specific, but still challenges for AI in general to solve. I foresee a very bright future for this lab, and the reason is that the three challenges that I mentioned that agriculture is facing are so pressing that we really need to do something. We need to have AI and robotic systems to support to go to a more sustainable agriculture. And for this reason, both government but also companies are very interested to fund the type of research that we're doing.